Hello everyone, my name is Warren Black. I was with the team marking question 14 for this year's Extension 1 HSC paper. Before I start, a couple of quick things. I want to thank the team that I marked with. They were a really good team, and as you could imagine, this wasn't the easiest of questions to mark, but they did a really good job. I also need to thank John Dillon, who was our supervisor, for his advice and guidance, which obviously was invaluable. Okay, other thing I want to mention is that pretty typically these sessions could be a little bit negative in that, you know, we don't have a lot of time, so we want to look at where students had trouble and what they were doing wrong and so on. But I want to start by saying I was really impressed with the number of students who did really well overall in this question, and it reflects well on the teachers across the state. In that they obviously are doing a good job, and the students who choose to take your advice and act on it and practice and so on are learning from you. And, you know, as I said, it was amazing. There were a lot of students who did a really good job on this difficult question, given that time is short and the pressure is on and all the rest of it. So good job, everyone. Now, where do they need to improve? Well, you can see there on my second dot point, students need to spend time improving their explain skills so that they can answer succinctly, but in using mathematical terms. Obviously, you can imagine we read plenty of essays, and that takes a lot of time, which worries me with regard to how students might go on other questions. But, you know, practicing those things would be a good thing. Also, you may have noticed that of the 7 parts, so there was part A and part B, and there were 4 parts to part A and 3 to part B. So 7 parts of a question that we had to mark here. Of those, 6 of the parts had the answer supplied. And so it's really important that students are able to justify their processes rather than just turning up with the answer. And in particular, A part 1 and B part 3, there were areas where students dropped steps and made it difficult for us to award them full marks. So have a look when we get to those. All right, so into the questions. So A part 1 was this question here where they had to use that identity given to them to show a result. So obviously the result was there. You can imagine pretty much every student gets the right result. However, a suggested solution is here. It's not the only only solution. However, what they really needed to do at the beginning was recognise that the 2NCN in the supplied answer was the coefficient of x to the power n in the first part of the identity, and then go looking for the coefficient of x to the power n in the second part of the identity. And a lot of students got to this stage here, which I'm trying to highlight with my mouse for you. Hopefully you can see that moving there. A lot of students got that. Then the justify part that I'm talking about is that students would move very quickly, and trying to get my mouse back, here we go, move very quickly from there straight to the supplied answer down here without using this Pascal's triangle coefficient relationship to explain how this thing turned up. And you know as well as I know that if an answer is supplied, then we've got some issues with, are they just copying the answer or do they know what they're doing? And I would really recommend that students took a little bit more time to ensure that we understood and that they had fully justified how they were getting their answer. So general comments, there were a number of students who didn't recognise the style of this question, where you're trying to equate coefficients from one side of the identity to the other. There were plenty of students who could not expand the binomial expression at all, which was a little bit disappointing. And as I've already said, some students weren't justifying their end result, and that's always a concern when the answer is supplied. Okay, on to part 2. So now we've got the club with 2N members in it, and half of them are men and half of them are women. And they're going to choose an equal number of men and women to form our group, and show, giving reasons, that the number of ways to do that is 2NCN. Now I'll just pop back to the slide before. Obviously, the 2NCN is the answer from the part 1, so they should be recognising that and hopefully coming up with the expanded method in part 1 to then get the 2NCN. So what's going on here? Well, here's another suggested solution, and you can see it's pretty well laid out in that we can choose 0 men and 0 women, 1 man, 1 woman, etc. And it's breaking it up into its small bits. That's what we really needed to see. There were a lot of explanations that were close, but maybe not close enough, and it was very hard to tell. But when a student did, and a lot of them did, like a lot of them, would say, okay, just like you can see there on the screen, 0 men, 0 women, 1 man, 1 woman, etc., etc., etc. So the total is same result from part 1 and get the 2NCN. So a lot did that. So try to suggest to your students that, you know, and I've said it here, better response, build the answer slowly, step by step, show the pattern and fully justify how they're getting it, because again, it was a supplied answer. And if it's a supplied answer, it's very difficult if it just pops out of nowhere. Okay, common problems. There were plenty of students who didn't understand the question, and I understand that, given that they may have been under significant time pressure by the time they get here, and they're asking themselves whether they can scribble down something quickly and then get back to doing something earlier in the paper. But if possible, these are the sorts of questions where you can use your reading time and take a fair bit of time reading it and thinking. A lot of students got tangled up on the even number situation and didn't realise it was pretty insignificant. The even numbers was the overall group, and by taking half from each, you got evens anyway. And there was confusion over situations where they didn't know whether they should be adding or subtracting or multiplying. So you can see here, we would multiply in this situation where we're looking at the ways of choosing the men and the ways of choosing the women, multiply to get the overall there. But then all of these individual results needed to be added. Now, we saw some confusion in amongst that. So it's worth practicing that with them. Okay, part 3 of the question. Now we're starting to choose leaders, and we're choosing the leaders from the group that has been chosen here. Okay, and in part 4, you probably have read the paper, you know that the leaders are going to be chosen beforehand. So what's going to happen here? Now, I'm sorry that the solution's a bit small, but it's getting more complicated, and it's the same in part 4. So once you've chosen your NC1 ways of choosing a woman, for example, then there's one way to choose the leader from there. And similarly for the men. So what ends up happening, sorry, I've said that wrong. We've chosen the one woman, and out of that one woman, no, I was right the first time. I'm getting confused with part 3 and part 4. We've got our NC1 leaders chosen, and one way to get the person in the group. Okay, so we end up with this NC1 squared multiplied by 1 squared for the way of choosing the 1 man and the 1 woman and the leaders for the group. Notice, no need to choose the zeros because there's no way to choose the leader from the one that you've got there. Okay, when we get down here, out of the n people, choose 2 to choose the 2 women, for example, and then out of those 2 women, choose one of them to be the leader there. Okay, and again, same as in the last part of the question, the idea is to build it up step by step. So that's what I've said here. The same comments as in part 2 hold, and also better responses were able to really clearly differentiate between the leader and the formation of the group. Okay, on to part 4. Now, it's pretty important in part 4 that they realise that even though they're reversing the process, the number of ways that it's going to end up is going to be the same. So the answer from part 3 and the answer from part 4 are going to match. And that's why it's saying find a simple expression for the sum in part 3. So again, it's a pretty big solution, but what we're doing this time is out of the n people, we choose the leaders first. So that's the n by n here. Choose the n women and choose the n men, choosing the leaders. And you can see that goes all the way down. What we were very much looking for is the students to then recognise that that means that the number of people in the group is now only n-1. And we can choose zeros from there, or we can choose ones or twos depending on the size of the group, all the way through to n-1c, n-1, and build this, and as before, add it together and factorise the n squareds out the front. Now, of course, this is where we've got to recognise that part 1 is still part of the solution, and this here is just another version of part 1, which can then be simplified to get that. And it didn't sort of fit very well, so I figured not to add it on, but ultimately they wanted to say, well, therefore this thing down the bottom here is equal to the answer in part 3. And so comments, better results, better responses. The students were able to express the choices of the leaders as the n squared, because we're choosing the leader first out of the total n people, and then some form of n-1ck for choosing the remaining members of the groups. Okay, common problems, not recognising the connection to the result from part 1. So to simplify this thing over here was an issue. And obviously, as we practice with the students in class, we do talk to them all the time about these long number of parts questions where you've always got to look for the connections back. So again, time problems are probably part of the issue here. And I've said, you know, these connections are an important part of the strategies. I'd like to ask you, did anyone have questions? But I've just got to move on. So here's part B. Now, this one, probably from a teacher's point of view, you look at this and you think, yep, that's not going to be too bad. I would say here that we saw every identity in the world combined in every possible way that you could imagine. And when you thought you'd seen them all, then you found another 3 different ways to do it as well. And unfortunately, what happened was a number of students overcomplicated things because they would use one identity for one part of this thing and another identity for another part. And while one part was being simplified, the other part was being overcomplicated, and they got themselves tied in massive knots, and you know, they weren't as successful as they probably should have been. So the solution that appealed to me the most was, as a teacher, I would look at the sine 3 theta and say, there's our problem. So let's go and just work on the sine 3 theta and simplify it, reorganize that identity there to get the one that we've got up the top here. But obviously, other correct methods were fine. There were a lot of students who used the sums and differences to products results or vice versa. And man, they got themselves in some knots, but plenty of them were successful as well. Now, what else happened? Well, better responses recognised this thing. Go with the sine 3 theta and work there. Now, I've put here clear and easy to follow algebraic steps. Some students were jumping steps and it made it very hard for us to follow. Again, the answer supplied. So if they jump too many steps, we're not sure if they've just written down the answer because they were hoping, or they actually knew what they were doing. I've mentioned this, the application of too many identities at the same time caused them problems. Algebraic errors, as you could imagine on something like this, there are plenty of algebraic errors. Now this last dot point was, you know, pretty interesting to me. The setting out of a formal proof was quite poor in a large number of cases. Now, the result up the top that we're looking for was all of the terms on the one side, but a number of students chose to work a left-hand side and a right-hand side here, which was quite good. But then they wouldn't keep them separate, and they'd work on both of them at the same time, which I thought was pretty poor. And then, even more to the point, when it wasn't working left-hand side equals right-hand side, but they did keep them separate, then they would do things where they would multiply their expression by 4 so that they could remove the denominator, but of course that wasn't correct unless they wrote something like 4 times the left-hand side equals. And I don't think I saw that a single once. So, you know, some of the organisation of their proof left quite a bit to be desired. Okay, part 2 of this thing says pretty clearly, let x equal 4 sine theta in that cubic equation. And so do that and end up with this sine 3 theta equals a half result. To me, that's a pretty easy sort of thing to do. Just do what it says. Surprisingly enough, a lot of students refused to make the substitution, even though they'd been clearly told to go and do that. Of the students who did make the substitution, there were plenty who, for one reason or another, didn't get the 64. We saw things like 4 sine cube theta rather than 64 sine cube theta. We saw things like 4 sine theta here or 12 sine theta, but missing the 48. So algebraic errors in amongst that substitution process were a problem. And then, as I said before, we're looking for connections to previous parts. So by the time they got this thing, they should be saying, hang on, most of that looks like something I had in part 1, and probably if I make a connection there, I'll get the end result. And again, we saw that happen in a lot of different ways, but they were correct and it was all good. So better responses were very, very efficient. They just did as they were told and away they went. And there were a lot of good quality responses here. Common problems, I've said it, failure to follow the instruction to substitute. I don't know why. And algebraic errors. Pretty easy. There's not much to learn there other than practice. And if a question tells you to do something, do it. Okay, part 3 of the question. Now this one's a 3-marker, so there's a lot more to do. Obviously it's the last question in the whole paper, so you're expecting some, I don't know, I don't want to say tricks, but maybe some twist in the tail there a little bit to make you think, and this one sure had it. So what have we got for the solution? And you can see there's a lot here as well. There was a lot to do for the 3 marks. The students needed to recognise that the way to go was that part 2 of the question had led them to this sine 3 theta equals a half, and that it wouldn't have led them there for no particular reason. So it was probably wise to start there and go and solve and get to this stage here where we had, there was no restricted domain on this solution. So let's just get a whole lot of answers. And most students did realise to get through as far as the 25 pi and 18 because they saw the 25 pi and 18 in the question and they thought, well, we better go that far. Problems arose then because students were not very strong at explaining why they were disregarding the 13 pi on 18 and the 17 pi on 18. Now there's a method of explaining that through here, that they're not distinct solutions. Students found lots of ways to do that correctly. Some version of explaining that sine pi on 18 is equal to sine 17 pi on 18 and similarly would have been enough to say, right, those 2 solutions are just doubling up on the first 2, and so therefore we'll just jump those and we've got to get a distinct root here. So earlier on when I started, I said, students have to fully justify everything they do. There were a lot of students who just, they saw the 25 pi and 18 in the answer, so beauty, I'll write that down, that's good enough for me. By the time they got their 3 roots, they then needed to realise that this was some version of a sums and products result that hopefully they had seen. And so then they needed to generate this. Now, obviously, there's the sum of the roots by 1, and here's the sum of the roots by 2. And hopefully they could reorganise it to get the alpha squared, beta squared, and gamma squared result. And things fell out pretty nicely from there. So to wrap up, 3 marks, lots to do. Recognise the connection to the previous part, recognise the need to generate that sums and products result. Common problems, inability to fully justify how to get the 3 distinct roots as opposed to just using the ones that were supplied in the answer. Confusion as to whether the roots were from the polynomial in part 2 or maybe the trigonometric equation from earlier. So that made things a little bit difficult for some students. And obviously, simple algebraic errors happened all through this question. Quite a few students, it would be wise to talk to your students. There are a number of them who just punched it into the calculator and said, yeah, it's right, it works. And probably they knew full well that for 3 marks at the end of the paper, that wasn't going to get them anywhere. So really, I thought they were probably just wasting their time writing all of that out when they maybe could have gone back to question 11 or so and had a bit of a look and tried to get an extra mark there if they didn't know what they were doing up here. Okay, again, I'd like to give you the opportunity to ask questions, but I don't have the chance, but that's the end of my presentation. I'll wrap up by saying, well done to my team, and I look forward to working with them again next year if I'm given the chance. Thanks very much.